A multiple choice quiz has 3 questions. Each question has 1 correct choice and 3 incorrect ones. Let's assume that the correct choice is randomly assigned to a letter. So just for argument's sake, let's say that A is the correct choice for number 1. That would mean the others are wrong. And for question 2, let's say that C was the correct choice. For question 3, A is the correct choice. Now that's totally random. But let's figure out if a student were to guess at the first question, what is the chance that they'll guess correctly on the first try? So we want to look at the tree for that question. And A was the correct choice, B was wrong, C was wrong, and D was wrong. But let's say the student didn't know that, and they just guessed. Well, then what we want to do is we want to look at how many choices are successes, and put that in the numerator, and then how many total possibilities. Well, there are 4 ways they could go here. So if they just guess at the correct answer, they have a 1 in 4 chance of guessing it correctly. Now let's look at that same tree and find the probability of them guessing wrong. Well, in that case, we see that there are 3 ways that they could choose wrongly out of 4 possibilities. So it's a 3 in 4 chance. Notice that the probability of getting the question right plus the probability of getting it wrong actually adds up to 1 because those ideas are complements. You're either going to get it right or wrong. Now let's take it farther. Let's say that the person's going to guess at all 3 questions. What's the chance that they will guess all 3 correctly? So we would need a much bigger tree diagram for that. First, it starts with the first question. But in order to get that one right, they have to take this top path. And they have a 1 in 4 chance of doing that. Now, off of each of those, we would have to draw the next question's tree. And that leads us to 4 more choices. We said that C was the correct one, though. And these guys would also have 4 choices on all of them, but we don't really need to draw them because we're looking for the probability of them getting all the questions right. So we don't really care if they get the first one wrong. That's not the path we need the person to take. We need them to take this path here. And then from there, they're going to have 4 more choices. And A was the correct choice for the third question. So we need them to take this path. Now, even though I didn't draw all the other branches of this big tree, we could still reason out how many ways they could arrive at all correct answers. The answer is, of course, just 1. There's only 1 way to get all the questions correct. You have to choose A, then C, then A. So our numerator is going to be a 1. The question is, what goes in the denominator? That's a little tricky to figure out. So what goes in the denominator is the total number of possible outcomes. When you have 4 choices for the first blank, 4 choices for the next question, and then 4 choices for the third. So how many total outcomes is it? It's actually 64. There would be 4 results first question, 4 possibilities for the next, and 4 possibilities for the last. So by the fundamental counting principle, we're looking at a 1 in 64 chance of guessing all of them correct. Just a little lower than you might expect from a probability. So the next question says, what's the chance of the person who's guessing getting at least one wrong? And so answering that requires that we look at the idea of getting all correct and look at that as a complement to getting at least one wrong. See, if you don't get them all correct, then no matter what you answered, you got at least one wrong. You must have traveled through a W somewhere in the tree. So there's actually only one way that you can get them all correct, and there will be 63 other ways that you can get at least one wrong. So the probability of all correct is a complement to probability of at least one wrong. So their probabilities add up to 1. And that's how we could solve this, even if we didn't use a tree. We could say that the probability of at least one wrong equals 1 minus the probability of all right. And since we were able to easily solve for that probability above, probability of them being all correct, we could just plug that in down here and solve for our answer. Now, if you get a common denominator there for the fractions here, we'd get 64 over 64 minus 1 over 64. And that takes us to the final answer, 63 over 64. That's the probability of getting at least one wrong. Okay, last one. And this one is kind of a myth buster here. It says, if the quiz is comprised of 3 total questions and the student were to take the strategy of picking A every time, then what is the probability that the student gets all 3 questions correct? Well, picking A every time, if the correct answers are randomly distributed, wouldn't really help you, unfortunately. So it would still be 1 out of 64. The only way that strategy would help you was if you knew that the teacher liked to assign the correct answers to A.